And thank you everybody for sticking around all this time. This has been a tremendous meetup event so far. I've learned a lot, and I hope you guys have too. So my name is Jacob, and I'm here to tell you about computer vision interfacing for vector search. So we've heard a lot from experts in vector search about things like reverse image search and how vector search is useful for computer vision. Today, I'm going to tell you about what we're doing at VoxelGPT in collaboration with a lot of these vector search companies and databases in order to make your life easier while you are using vector search in your computer vision workflows. So who am I? I'm Jacob. I am a machine learning engineer and developer evangelist here at VoxelGPT. I've been with the team for about 9 months now. Prior to joining the team, I completed my PhD at Stanford. My background is in physics. Who are we? VoxelGPT are the lead maintainers of the open source FiftyOne toolset. So in a few of the presentations, in Philip's presentation and Ayusha's presentation, we saw some demos, some visualizations of vector search in action, and those were utilizing the FiftyOne toolset. And I'm going to show you a couple of other visualizations using FiftyOne as we go forward. The company itself was developed, it was created by two founders, Jason Corso and Brian Moore, both of whom did work in computer vision at the University of Michigan and other places. They are both experts in machine learning and computer vision and have been working in the field for a decade plus. Our team consists of about 25 really talented, really dedicated computer vision, machine learning, and software practitioners. And we all came together under the aspiration of bringing visibility, bringing transparency and clarity to the world's data. So as we've heard in a lot of these presentations, data quality is oftentimes the limiting factor in machine learning applications. So this company and the tool that we are developing is all about helping people to understand their data so they can build higher quality models. And for those working in machine learning and computer vision, it's all too familiar that bad data is the villain of machine learning and computer vision. So it can have negative consequences like racial biases, actual physical harm, and reductions in model performance. So if you want state-of-the-art performance, and if you want to avoid all of these potential tragedies, then you need to understand your data and build higher quality data set. Now, to do that, VoxelGPT built and maintains open source platform FiftyOne, which is, in a nutshell, a tool set for helping you visualize, clean, and curate your data, find hidden structure, evaluate models, and it is very flexible, very customizable, and connected. There's a lot that we could talk about with this tool set. I'm not going to talk about all of it. I'm just going to talk about one specific piece of it, and that is the part about finding and searching your data that is related to vector search. So I mentioned that FiftyOne is very flexible. It's actually so flexible. So this is the query language. We've got so much documentation on it. It's such a flexible language that has so many different query operations for slicing and dicing your data that we actually went on a bit of a journey ourselves with large language models and vector search applied to textual data in order to make our documentation searchable. So this is a project that you can see online. You can go to the GitHub repo. We have blog posts on it. There's a lot of resources if you want to check it out yourself. This is just a visual on the left-hand side here of the command line interface, actually popping out the couple of best results given your query. And for this, we use vector search. So we used Qdrant in order to basically, we split up the documentation into a bunch of small chunks. And we use Qdrant to make the docs searchable. So when a user input a text query, we use an embedding model to embed that text query and compare that to pre-computed embeddings for all of these little chunks of the docs. And using vector search, searching over these thousands of different chunks, you can actually find which ones have the best alignment. After that, we actually went on another adventure, another journey. We made VoxelGPT. So this was also an attempt to combat the woes that people sometimes experience when they are getting into FiftyOne because it is just such a flexible and versatile tool set. So we built this large language model and vector search powered application that allows you to ask questions to this model and have the model basically with access to all of our documentation answer your questions, as well as turn your natural language queries into Python queries in the 51 query language. So there's resources on that if you want, blog posts, again, repo, all of that good stuff. Now, interesting thing about this is we started out trying to use a vector database for this. We were using ChromaDB, if you guys are familiar with that one. But we actually found that we got better performance without using that, because the chunk size that we were splitting the docs into in order to maintain some sense of context for the model was actually so large that we had way fewer chunks than we had when we were doing the doc search project. But both of these give us a lot of familiarity with large language model vector search applications. But that's not what we're here about to talk about today. We are talking about vector search in computer vision. So in large language model vector search applications, this is just a typical visual of what it looks like. Again, from application to application, it can look much different, but this is a very high level schematic of what it looks like. So you have data. That data is embedded in some way. The vector database comes in order to basically act as an extension to the memory system for these large language models. So instead of, with the limited context length or context windows of these large language models, they can only take in a certain amount of data. But if you have way more data than that you want these models to have effective access to, you can use these vector databases in order to basically find the most relevant, the most important chunks of whatever database of content you have and feed those in as context. There's more to it than that, but that is the essence of it. And this is in many large language model vector search, vector database applications. This is what it looks like. So it's an expansion of the memory. It is a lookup and retrieval system, but it is internal. It's not exposed to the user. So the user doesn't actually see directly the results of these vector searches. And because of that, this is very non-interactive. So the user interacts with the application. They might be interacting with the large language model, but they don't really interact with the vector search results themselves. And this is what we did when we were building out doc search and VoxelGPT. So here is a overview, high level of what VoxelGPT looks like. So I'm not going to go into all the details here, but you can see in the middle stage, we have doc search, where we basically find pieces of the docs that are relevant and feed those in. For example mining, when we find the relevant examples of pairs of natural language and Python queries, that we basically find the most relevant natural language queries and then feed those with the Python queries into the model for it to try to predict what the relevant or what the best Python query is to generate given that user's natural language query. So this is what it looks like. Again, it's not exposed to the user. But in computer vision, it's different. And it's not always different, but for the most part, it's different. And we've had multiple speakers today talk about reverse image search. And that in and of itself is an application in computer vision. So you feed in an image and you want to get an image or a couple of images back. You can, in Google, you can do reverse image search on any of your images to figure out, what is this? Like, where could I buy this again? We looked at a bunch of retail use cases in some of the prior speeches today. You can also do fun things like celebrity lookalikes. So you put a picture of yourself in and it searches against a database of a bunch of celebrity faces and find the most relevant ones. But today, I want to talk to you about something slightly different than this. So it uses vector search and it is still exposed to the user, but it is for more of an exploration purpose. And that is because in a lot of computer vision applications, vector search comes in as a way to understand your data better. So 51 was built to help you to curate, to sort, select, exclude, to filter your data. Vector search is a huge piece of that. And so in particular, vector search comes in a lot of computer vision applications in two stages. First, when you collect and process the initial data, you can use it to understand and curate the data. So you can do a lot of initial exploration. So this is unstructured exploration. You can use natural language search to do a semantic search powered by this underlying vector search in order to very quickly explore the data, figure out what's going on, get a sense for patterns and trends. And then when you start the loop of data training, training your model and deploying the model and finding problems and updating the data set, and you go through this loop multiple times, the finding problems piece is also a piece where vector search comes in handy. And this is unlike large language model-based applications because this is completely interactive. So I mentioned that vector search is just a piece of this exploration. It is a huge piece of it, but it's part of a larger tool set. So filtering, excluding, searching, selecting, and sorting, these are all the types of operations that you may want to do. And many of these are efficient using classical mechanisms. But if you were to try to search over 1 billion images with the types of vector search operations, if you were to try to do semantic searches over these 1 billion images with traditional methods, just basically comparing the vectors one by one, it would take forever. It doesn't scale. It would not be a feasible way to explore the data. So that's where vector search comes in here. This is what data curation looks like in 51. Just a simple example here where we are sorting by something called uniqueness, which is a measure of how unique each individual sample is relative to the other samples in the data set. Then you can filter by certain things. You can basically filter by confidence thresholds for detections, lots of stuff. There's a wide variety of things that you can do when it comes to data curation. And we worked with a lot of the leading vector database providers in order to integrate vector search natively into 51, so that when you are using vector search for your computer vision and machine learning data exploration, you don't have to worry about a lot of the minor details. Those are all taken care of for you. So here we see an example of choosing 2 images of cats, and then we are going to search by similarity, and we find a bunch of images of cats. And behind the scenes, this is using I think in this case, a Qdrant vector database. Now, I'm going to tell you about a couple of the ways in which it makes your life easier. So one is natural language image search. So the way that we built all of this in collaboration with these vector search engine providers is the underlying vector database is used in a similarity index in 51, and the 51 wrapper around it knows whether your model supports prompts, whether it supports multimodal embeddings, like we talked about CLIP earlier in a couple of the presentations, or BLIP, or whatever other multimodal embedding model you want. So it knows whether the model actually supports those multimodal embeddings. And so if it does, then it actually allows you to search with natural language. If not, then it just allows you to search via image similarity. You can also search over objects. So we had in a couple of the presentations examples of object search. So if you want to look for the shoes in an image and find similar shoes across all the images in your data set, this is also something that is very easy to do in 51. And this otherwise would be somewhat arduous of a process to set up. And you can pair this with prefilters. So one of the key components of vector search engines is that you can feed in filters. So you can filter after, sure. So you can run your vector search and then filter on top of that. But if you want to get a set number of results out at the end of the day, so you want to find the 20 most common or most similar examples that fit certain conditions, you need to do that filtering for conditions ahead of time. And a lot of these vector search engines support those capabilities. 51, in our integrations with these vector search engines, we built in all that pre-filtering so that you can not have to worry about any of that. You can just select these filters within 51 and have all of that automatically ported into and utilized in the vector search as pre-filters. And this is a key component of what it means to be interactive for us when it comes to data exploration. So you can set and remove and update and adapt these filters however you like and get a new view into your data set. You can use these vector search in conjunction with pre-filters in whatever mixed and matched way you want. So You can also do this in videos. So you can look at the frames of videos and do either image or natural language-based search or object search within these videos. And as I mentioned, you can mix and match. So here we have an example where we filter for cars. We find an example car. We do an image similarity search within that. We get the object patches, and then we look at tires, do a natural language search for tires because we don't have that label on our data already. So we've combined a bunch of vector search-based operations with a bunch of other non-vector search operations, all in this exploratory spirit. And if you were to not have this 51 vector database connection, then it would be so much more difficult to go from one individual type of search to another. It would require a lot of manual and tedious work. So this makes your life so much easier and allows you to explore and build out your own workflows. How does this work? I'm not going to get into too many of the details, but on a high level, this works because 51 has a unique label and sample ID. So every one of these samples, whether they're an image or a video or another media type, each media file, each sample is associated with a unique identifier. And each label, whether that's a detection or a segmentation mask or a classification within any individual image, is associated with the unique identifier as well. And these allow us to map from those media files to the positions, basically to the vectors and in our vector index. So here's a label ID. And then we have this concept of a dataset view. So we're doing a lot of filtering. So in this GIF, we have some filters that we're applying. We're matching based on tags, and we're sorting based on a property uniqueness that I mentioned before. And these are stages of a logical pipeline that contains or captures all of this logic in what we call a dataset view or a view into your data. And that takes care of all of these filters for you. So you don't have to worry about if you are updating, adding a stage or taking a stage out or shuffling things around, whatever you want. This takes care of all the logic for you. So you don't need to worry about changing up your pre-filters that you're putting into the vector database at any time. And there's also support for whether the model has prompts or not. So whether the model is multimodal, we keep track of that. We keep track of whether this is applied to your object patches or the entire images. There's a lot of other stuff that is tracked behind the scenes to make all of this happen. Again, not going to go too deep into the weeds here, but the point is that we've done all the work so you don't have to, and you can get to exploring and using vector search as an enabler in conjunction with traditional pre-filters and sorting and slicing and semantically dicing your data so that you can find issues and better understand your data and build better models. And in addition to all of that, there's also, this is all accessible via Python. There is a very simple Python SDK API. You can also do things like to actually modify the vector index itself directly via this API. So you can add things to your index. If you add samples to your data set, you can add the corresponding embeddings to the similarity index that is underlying it. You can remove things from the index just as you are removing samples from the data set. You can also get the embeddings. So we have methods that allow you to basically get the embeddings so that you can use them for dimensionality reduction and visualization or whatever other type of thing you might want to do with them. And then we even have methods to clean this all up at the end of the day. So a lot of this is taken care of for you so you can focus on the important stuff. And how do you get started? Well, we have a bunch of resources. We have a couple of blog posts. You can find these on the VoxelGPT blog, or you can find these on Medium. We also have very extensive user guide documentation about what the Similarity API is in the 51 Brain, which is our machine learning toolkit, as well as using the app. So a lot of the GIFs I showed you were in the app, and that was all sorting by similarity and stuff like that. There's extensive documentation about all of this stuff. And I just want to give a huge thanks to Qdrant, Zilliz, Milvis, LandsDB and Pinecone. All of these companies, all of these teams are tremendous, and they worked with us to make this happen. They're pushing forward computer vision and so much else with their work. So thank you to all of them for their tremendous work with vector search and computer vision. And if you liked what you saw today, if you liked the meetup, if you enjoyed this presentation, please give us a star on GitHub, the VoxelGPT project. We really appreciate it. And follow us on LinkedIn, and you can try out 51 for free and VoxelGPT, as I mentioned earlier, at try.51.ai. So thank you so much. All right, I'm going to look at the Q&A.
Got a question.
There's a question about whether 51 can be used for non-computer vision applications. So it depends what you mean exactly. So some people talk about, like, for instance, point cloud-based applications. That's not necessarily computer vision, but we can do those things as well. People do things with purely text data in 51. If you're using purely like tabular data, I would say that 51 is probably not the best platform for you, but rest assured that more multimodal applications and functionality are coming very soon.
All right, well, if you've got any burning questions for Jacob, make sure to ask those.
And we had a question about VoxelGPT. Yes, there is a large language model behind VoxelGPT, and that large language model initially was GPT-4 with a lot of prompt engineering and a lot of software engineering and elbow grease put into it. But in order to make it more cost effective for people who are using it locally, people who are using this because it is open source, we actually switched to GPT 3.5, which made our lives a lot harder, but makes your life a lot easier and makes it a lot cheaper for you. Oh, the QR code. There you go.
All right, so with that said, again, echoing Jacob's words here, looks like we have one last one here.
Okay, this is a general question about embeddings. So when you're dealing with multimodal embeddings, typically they train a model in order to make certain pairs of embeddings or certain groups of embeddings from different modalities close to each other, and pairs that are not from the same, that are not similar, far away from each other. So the simplest thing that I could that you could use to actually understand this is CLIP, which is contrastive language image pre-training by OpenAI. They have tons of resources on this. That's just text and images. But ImageBind recently came out, which basically does this for 6 modalities all at the same time. Every approach is slightly different, but you can't just take like an embedding from one embedding model and embedding from another embedding model for different modalities and compare them. That won't work, probably. But if you take a model that has been trained and designed to work with multiple modalities, then it should work.